Hello, math students. Welcome back to our module on linear equations. This is lesson 16, and it is called the computation of the slope of a non-vertical line. Our goal for today we will learn how to find slope when a graph has not been drawn. The question that I want you to think about is, what is the easiest and most efficient way to determine the rate of change of a line? All right, so we've been working on trying to figure out what linear equations look like when you graph them on a line, and you have spent a lot of time taking ordered pairs and graphing them and then seeing if the line that connects them is straight, and if it is, that tells you that it's a linear equation. Well, today you need to be able to see a line that's already been graphed, and you need to be able to name the equation that supports that, but you also have to be able to take an equation and you have to be able to determine the slope if you don't have access to a graph, because there's going to be many times where you don't have room to draw a graph, and also you need to be able to identify it mathematically instead of just visually. So I would like to show you that. So on the things to remember, the first thing that I would like to start out with is, can you take a look at this graph right here and determine what the slope is of this line? So let me zoom in a little bit so we can see a bigger picture of this. Okay, and so we have this graph that's already been graphed for us. There is a line, it is straight, and so your job is to determine what is the slope. Now what you have to remember about slope is that slope means the comparison, right? The comparison of how much the line rises divided by how much the line runs. Okay, so you're always comparing the number of ups to the number of overs, and so that's why we call it the comparison of how much the line rises compared to how much it runs. And so rises means that you're going up or down, remember, and runs means that you're going to the left or to the right. And so we're going to count those. So when you have a line already done for you, the best way to figuring out the slope is find positions on the line that cross exactly on a whole number. So we see that it crosses right here at the origin, and then the next one I see that it crosses exactly at a number. It would be at that point right there. The next one that I see from there is right there, and then I have one here, and then if I go the other direction I can find it by finding that one, by that one, and then I would say again that one. And so we have several points that we can compare this to, but basically what you're going to say is, if you start at the origin, then you know that we went up one, so we rose one, right? And then we went to the right, 1, 2, 3. So we ran to the right 3 times. Notice up means it's a positive 1, and to the right means that it is a positive 3. If we were to go the other way, we could still get the same thing, because now we're going down 1, so that would be a negative 1, and to the left 3, 1, 2, 3. And you remember the rules that a negative divided by a negative is a positive, so these are actually equivalent. Okay, and so that's how you're able to find the slope. The slope is rise over run. So how did you go? We went up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. And you will notice that every time we go up 1 and to the right 3, the new ordered pair or the new point on the line, it actually sits on the line. And you can do the same thing going backwards, because you would just say down 1 to the left 3, down 1 to the left 3, down 1 to the left 3, and you end up with the same slope taking place. And so showing this tells us that our slope is 1/3. And that's how you determine the slope of a line when you have a graph, is you're looking for the exact positions where it crosses exactly on a whole number spot, and then you count what happened in the exchange. Okay, so that's how you determine the slope of a line that's already graphed. Okay, so then the next thing that it's asking us to do in this practice is, how do we find the slope when it is written in an equation? And this actually right here, if you're looking at it, this is standard form. Just to remind you what standard form is, ax plus by equals c. So that's written in standard form. And so to find the slope of the equation, again, the best way that I would suggest that you do this is you would just turn it from, so this is standard form, remember, I would say the best way to find the slope is to turn it from standard form into slope-intercept form. So that's where we're going with this one, is we're going to take it into slope-intercept form. And another name for that is also the y-intercept form, right? So basically what you're going to do is you're going to say, okay, subtract 6x from both sides, right? So we do that, and we get a zero pair here, and we're left with 2y equals a negative 6x plus a positive 12, right? And we're almost there. So then the last step is that we have to divide everything, every term, not just one side, but every term. So 2y divided by 2 actually gives us y equals negative 6x divided by 2 gives me a negative 3x, and then plus 12 divided by 2 is 6. And then, if you remember, this is slope-intercept form, y equals mx plus b. And so we know that the b would be equal to 6, and we know that the slope, or the m, is equal to a negative 3. And so the slope for this equation right here, 6x plus 2y equals 12, your slope is negative 3. And so our line, if you're picturing it without even graphing it, your line is going to be something like this. You're going in the negative direction. So remember, a negative slope means that the line is traveling down when you go from right to left. So that's a negative slope, okay? So we found the slope of that line. So that wasn't too bad, okay? So when you're doing a graph, again, you count the amount of rises divided by the amount of runs. If you're given the equation, you take it from standard form and turn it into slope-intercept form, and then you can find your slope by remembering the y-intercept form, okay? So then it says sometimes we must be able to find the slope without graphing, all right? And so we're not going to have a picture at all. And so basically what you have to do, if you're not allowed to graph it, is you're going to use the ordered pairs of 2 points that sit on a line. So I'm going to just do a hypothetical and say that we have a line that has points that sit at 5, 2, and the other point that we have is at negative 3, 1. Okay, so those are our 2 points. Okay, so use ordered pairs of 2 points. There they are. All right, label the points point 1. So we're going to call this one point 1. Okay, and point 2. So this one is called point 2. And then compare the differences between the y values and the differences between the x values. And you remember that compare means we're dividing. So we're actually going to have a fraction bar here, and it says compare the differences between the y values and the x values. So in order to do that, basically what it's saying is we need to know what is the difference between these guys, because those are the y's, and we need to know what is the difference between these guys, because those are the x's. Okay, so finding the differences means that you're going to take either point, it doesn't matter, but we have to find the distance between the two. So I'm going to say that I'm taking 2 minus 1, because that's how you find the difference. And since I started with this 2 being first, I have to start with the 5 first for the x's. You can't flip-flop them. They have to start from the same point. So this is the point we started with. This is the point we ended with. So this is the point we have to start with. So 5 minus a negative 3. Okay? And so now you know how to work with integers. So basically, you're just going to simplify what it asked us to do there. And we get 2 minus 1 is 1. And then 5 minus a negative 3 is actually, remember, subtraction is the same as adding the opposite. So it would be 8. And so our slope for these 2 points right here would be, so m equals 1/8. So for every 1 we rise, we go to the right 8. So your line is going to be traveling in the positive direction, right? So it would look somewhere like here. And then for every 1 you go up, you go over 8. Up 1 over 8, up 1 over 8, up 1 over 8. So your line is actually going to look like, let's say here, so we would go up 1 and over 8. So pretend that's there. And so your line is going to look something like that. Okay, that's what your line is going to look like. very roughly, because we're not actually graphing it, but that's what it would look like if you actually drew it, okay? So it means that you're traveling up 1 and over 8 every time you go. So that would be the slope, okay? So we basically talked about 3 different ways that you can find the slope of a line based on what you're given. If you're given it on a graph, then you just literally calculate how much does it go up by how much does it go over. So how many rises over how many runs. And we showed that on there. Key point of this one is go by the whole numbers, and then you can count evenly. Okay? If you're given an equation written in standard form, the best way to deal with this one is to turn it into slope-intercept form, and once you have that, then it's very easy to identify the slope because it's right there. It's labeled for you. Okay? And then the last way to do it, if you're not allowed to graph and it's not written in an equation for you, then you just pick 2 ordered pairs that are on the line. So I picked 2 of the ordered pairs that are on the line, and then it says label 0.1 and 0.2, and then comparing means you divide them. So we're going to compare the y values. Remember, these are the y values. It always has to be the y values. So compare the y values. Let me write that over here. Y values by the x values. Okay? And you got to remember, it's the rise, and the reason why it has to be the y values on the top, let's talk about that, because remember up above we said you have to calculate the rise divided by the run. So the y values always tell us the rise, right? And the run values always tell us the left and right, which is your x value. Okay, so that's why you always compare the y's, find the difference between the two, and you compare them to the x values by finding the difference of the two, okay? And so that's how you're able to do that using 2 points. All right, let's go back to our goal. Our goal for today was, today we will learn how to find the slope when the graph has not been drawn. So we showed you those 3 different ways. What is the easiest and most efficient way to determine the rate of change of a line? I would definitely say if you have the line, the easiest way is to count it. If you don't have the line and you're given an equation, the easiest way is to turn it into slope-intercept form. And then if you don't have that and you just have 2 points, then you take the 2 points, find the y values, the difference between them, find the x values and the difference between them, and then compare them, rise over run. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye!